Good morning. Our next topic for exponents is going to deal with something called rational exponents. So we've talked a lot about exponents so far. We've seen them in previous years, but with our rational exponents, it's a little bit different. Okay, they just look a bit different. They work the exact same way. Okay, so rational exponents are exponents that are fractions. Okay, they're exponents that are fractions. Now, these rational exponents will allow us to rewrite them as radical expressions. Okay, so they can be rewritten as radical expressions. Now, we've not talked about radicals, but we have talked about something that's similar to radicals, and that's called square roots. The word radical is sort of the overarching term. So all square roots are radicals, but not all radicals are square roots. Okay, so we don't just call them radicals, we can also call them roots. So also called roots. And if we recall from the idea of the square root that we have seen, it's the inverse operation. Inverse operation of an exponent. Okay, so we remember when we solved by inspection, we just took the square root of both sides. When we saw x squared, square root of that, it gives us x. So it undoes that exponential expression there. All right, so our symbol, which we should be familiar with. Now it's going to look a little bit different sometimes because we're going to add something that we call an index. And then we'll just make the note here just to remind ourselves that square root is a type of radical. Okay, so that's the experience that we have with radicals so far, square roots, and we're going to kind of see why that makes sense. So hopefully we've done our think, pair, share. We've looked at some of our exponent properties and some of our radicals and put those in the calculator and kind of seen maybe some patterns, but now we're going to kind of solidify those patterns here. So we're going to talk about notation before we talk about radical versus exponential form. Okay, so with our notation, is going to look like this. Okay, now I'm going to label a few things here. I'll draw some arrows. So we have our first thing is we have the radical symbol. Okay, so that's this little, maybe, I don't know, check mark and then flat part. It's just like the square root symbol, radical symbol. That's what we call it there. Now, the most important part that we need to be familiar with is the index, because that's what's going to change when we are rewriting our radicals and our exponents. Now, this b inside the radical, we call that the radicand. Okay, that's the radicand inside the radical. Now, when we make an equality statement here and say equals, I'm going to keep b. My exponent here is going to stay here. Now, my new exponent is going to be m over n. Okay, so now we have a rational exponent. Okay, this right here, this m over n, is a rational exponent because it's a fraction. Okay, now we're looking for patterns here. The radicand and the base are the same. Okay, the index and the denominator of my rational exponent are the same. Okay, and we'll see that a bit in our examples here below. Okay, so when we're rewriting into radical form from exponential form, or vice versa, We're going to start with our radical. We have something inside the radical, our radicand, and an index. If we don't have an exponent out here, our numerator is going to be 1. Okay, because we know the exponent of something. If I don't see an exponent, the exponent is always 1. Okay, so we have the nth root of b equals b to the 1 over n. Now, we can go back and forth between those, and we'll do a couple here. So here's one example, the cube root of 12x. Notice how there's no exponent here, so we just have an index. So we're going to go ahead and keep our base. Now, key here is our base must be in parentheses. Okay, if it's in our radical, it has to go in parentheses. If it's in parentheses, it has to go in the radical. Okay, this radical serves as a grouping mechanism. Our parentheses are a grouping mechanism. Our exponent here is going to be 1 over 3. Now, let's go ahead and go backwards. So we are going to have 4y raised to the 1/5 power. Okay, there's our rational exponent. So we're going to make our radical symbol. What's inside parentheses, what's getting the exponent, has to go inside our radical. That's our radicand. And then our index is our denominator. Okay. So see, we've got our patterns here. 3 is our index, 3 is our denominator. 5 is our denominator, 5 is our index. Okay, we're trying to make those connections here. Now, sometimes we will have a numerator for our rational exponent. Well, it might have an exponent in our radicand or outside of our radical. And so we'll take a look at that real quick as well. So, if I have this expression here, the cube root of 2x raised to the 5th power is equal to, now, I have a radical symbol, that's my grouping mechanism. So I'm going to put that in parentheses, my 2x goes in parentheses. My 5 stays out here as the exponent, and now my denominator is my index. 3 and 3 is my denominator here. Okay. Now, let's go ahead and go the other direction. I've got 3y raised to the 7 over 2 power. Okay. Now, I'm going to do my radical. 3y is in my parentheses, so it stays in my radical. I'm going to do parentheses to get my exponent. My numerator is 7, stays the exponent. Now, when we do square roots, we never see a 2 here. We do not write the 2 if the index is 2. Okay, and that comes to our little summary sentence down here. So if there is no index, it's square root. So we want to use a 2. Okay, so we were given a 2 here, so we don't write the 2 for the index. If we didn't have the 2 for the index, we would write the 2 out here. Okay, that's one of the biggest mistakes I see. That and not using parentheses. Okay, so let's do a couple examples here. So we've got the square root of 5n. Now I don't see an index, so that means my index has to be 2. So 5n, make sure that goes in parentheses. Exponent is 1 over 2. Now we have the square root of 7r cubed. So once again, I don't see an index here. I can write a little 2 there. So my base is 7r, it's in parentheses, it was inside the radical here. My numerator stays as my main exponent. My denominator is my index. There's my 2. Now if we're going back into radical form, so we draw our radical here, keep our base inside. If it's in the parentheses, it needs to go inside the radical. Now my index is 3, because that's my denominator, and then I'm going to take all this squared. All right, our last one here. Now, I have a negative exponent. I don't like negative exponents. I'm going to go 1 over 5x in parentheses to the 3 over 2 power. And now I can do my rational exponent into my radical form. So radical, 5x is inside my radical. My index is 2. I'm not going to write 2. And then I'm going to put parentheses cubed. Okay? So the main reason I like to rewrite into exponential form or into radical form is because it will make some of our equations easier to work with, particularly when you get into some higher level mathematics, as well as solving some of our equations later on. All right, so go ahead and answer the last couple of Edpuzzle questions before working on the practice.